Good afternoon, learners. Having learned of the ionic bond that results from a metal and a non-metal and understood the characteristics and the various examples of ionic bonds, today I want us to look at the other categories of bonds, which are what we call as the covalent bonding, which results to covalent compounds. But what are covalent compounds? Covalent compounds are compounds composed of atoms that are bonded to each other through the sharing of electrons. Remember, when we were talking about ionic bonds, we say that ionic bonds are formed as a result of a metal transferring or losing electrons to a non-metal. That is, a metal loses electrons while a non-metal gains electrons. However, in the case of covalent compounds, we are saying that none of them is lost or none of them is transferred. Neither is the formation of positive or negative cations or anions respectively occurs. There is no metals in this case. That we are saying that in this case, two nonmetals come together through the sharing of electrons. And as I repeat, that electrons in this case are not transferred, and there is no involvement of cations or anions. Also, the resultant is what we call as molecules. Examples include water, carbon dioxide, chloride gas, and methane. We will see some of the examples of some of these structures as we move on. But see the way the electrons are shared. This is hydrogen gas, oxygen gas, nitrogen, chloride, nitrogen oxide, water, nitrogen dioxide, and carbon dioxide. How does the sharing of electrons occur? When you look at the case of hydrogen, a hydrogen cation means that it has a charge of 1 and it requires to lose 1 electron to gain what we are calling as a duet state, just as the case with helium. The other case, this means that two hydrogen atoms, for them to come together to form hydrogen gas, they have to share the 1 electrons from each one of them to get a duet state, and that is what we refer to as hydrogen gas. In the case of water, is that we have molecules of hydrogen and 1 molecule of oxygen. Oxygen has got 6 electrons in its outermost shell, while hydrogen has got 1. Oxygen requires 2 electrons. It requires to gain 2 electrons for it to get to an octet state. However, the hydrogen cannot be lost. It can only be shared because the hydrogen also requires another one to gain its duet state. Therefore, the hydrogen and the oxygen end up sharing electrons. Look at this case. The hydrogen and the oxygen are sharing these 2 electrons, and the same case as here, so that they can get to a stable state. Remember, we are saying that for the case of hydrogen, the stable state is a duet state, but for the case of oxygen, the stable state is an octet state. Let us look at other examples of covalent bonds. In the case of methane, methane is made of carbon and 4 hydrogen atoms. Methane requires, being carbon, it has got 4 electrons in its outermost shell and requires to gain 4 so that it can get an octet state. Hydrogen, on the other hand, requires only 1 atom so that it can get a duet state. It is with this case that they end up sharing the electrons of the 4 they end up sharing the electrons so that both of them can get an octet state into what we call as methane. The case of ethylene. Ethylene has got 2 carbon atoms and 4 hydrogen atoms, and they end up sharing the electrons for the hydrogen to get a duet state. and the carbon to get an octet state. It is the same case for formaldehyde and acetylene. But how is it that they share these electrons? I have given 4 examples of methane, ammonia, water, and carbon dioxide to represent or to show how the electrons are shared between the various elements so that all of them get an octet, either an octet or a duet state in the case of hydrogen and helium. Have a look at the case of methane. Is that carbon, which we are saying has got four electrons in its outermost shell, ends up sharing the one electron in hydrogen, so that each one of the hydrogens gets a duet state, and so does the carbon get the octet state. This is the same case for ammonia. Ammonia is made of three hydrogen atoms and one nitrogen atom. Nitrogen in its outermost shell is deficient of 3 electrons. That is, it requires to gain 3 electrons for it to get to an octet state. Therefore, it ends up sharing them with 3 hydrogen atoms to get to form ammonia. Water, on the other hand, is made of oxygen and 2 hydrogen atoms. Oxygen is deficient of 2 electrons in its outermost shell, and it ends up sharing with those of the 2 hydrogen atoms to get to an octet state. This is the same case in the case of carbon dioxide, where the carbon is deficient of 4 electrons, while the oxygen is deficient of 2 electrons. Therefore, they end up sharing the electrons in what will form a double bond so that both of them can be in an octet state. I have also prepared some of these questions. You can look at these questions and draw the diagrams to represent the bond in each of the following covalent compounds. This is tetrachloromethane, oxygen gas, hydrogen sulfide, and hydrogen chloride, ethene, methanol, and nitrogen gas. Remember, for you to be able to draw these diagrams, just as was the case for the ionic compounds, you have to know, in the case of tetrachloromethane, how many, in the case of tetrachloromethane, how many electrons does carbon require for it to get into a stable state, and how many electrons does chloride require to get into an octet state? If this is the case, how will be the sharing? Will it be in a single bond, a double bond, or a triple bond? The same case for oxygen. How many electrons does one oxygen atom require to get to an octet state? And how is the sharing going to be? Is it in a single, double, or triple bond? And the same case for all these others. Then we need to look at the properties of various molecular substances, that is, various substances that result as a result of covalent bonding. They have a low melting point, low temperature, and low boiling point temperature. They have low melting point temperature and low boiling point temperatures, and they are relatively soft compared to ionic compounds. They are also non-conductors of electricity in any phase, whether solid, liquid, or gaseous form. And this is because they result from sharing of electrons, unlike ionic compounds that result from the sharing and the transfer of electrons. So let us look at these elements. Nitrogen dioxide, sodium hydride, mercury, hydrogen sulfide gas, sulfate, carbon monoxide, and carbon dioxide. When you are asked, is this a result of covalent bonding? Is it a result of ionic bonding or is it a result of metallic bonding? What makes you know whether it is a covalent, ionic, or metallic bond? Remember what we have said the three are. A covalent bond results from a nonmetal sharing electrons with another nonmetal. An ionic compound results from the transfer of electrons from a metal to a nonmetal. A metallic bond results as an interaction of different metals. For instance, if I was to answer this question, nitrogen dioxide is as a result of a covalent bond because it has got nitrogen, which is a nonmetal, and oxygen, which is a nonmetal. In the case of sodium hydride, it is as a result of a metallic bond because sodium is a metal and hydrogen, which is as a result, hydrogen is a cation that shares one electron. Therefore, both of them have got a cationic state, therefore are metallic bonds. When you look at the case of mercury, mercury is a heavy metal with a positive charge of 2. Therefore, if there are many and they are dissolved in water, they only form a positive state, a positive charge, hence a metallic bonding. You can try to answer these or with as many compounds as you can. Differentiate them between a covalent, ionic, or metallic bond. Look at the case of ammonium. Ammonium has a positive charge. Therefore, you expect once it is dissolved, it only has positive charges, and hence a metallic bond. The case of aluminium phosphate. Aluminium phosphate is as a result of aluminium, which is a metal, and phosphorus, which is a non-metal. Therefore, an ionic bond. You can try these with as many compounds as not limited to this slide. Then before we look at the various types of covalent bonds, I want us to look at an aspect called electronegativity. Electronegativity is a measure of the ability of an atom to attract electrons to itself. This we had seen when we were looking at the beginning of the previous class, when we said that the attraction of the transfer of electrons from a metal to a non-metal is dependent on their electronegativity. And we are saying that this is a measure of the ability of an atom to attract electrons to itself. For instance, in the case of sodium chloride, electronegativity is the ability of chloride to attract electrons from sodium so that it can be stable to form sodium chloride salt. How does it behave within a periodic table? In a periodic table, electronegativity increases across periods, that is, from left to right, that is, from group 1 to group 18. It also decreases down the group, that is, from top to bottom, what we refer to as from top to bottom, that is how much electronegativity decreases. Therefore, when we look at a periodic table, we will see that we are saying that electronegativity increases across the various periods from left to right. Therefore, saying that an atom like hydrogen has got low electronegativity compared to fluoride. We are also saying that electronegativity tends to increase from top to bottom. Therefore, we are saying that hydrogen has got high electronegativity compared to francium. So generally, when you look at the periodic table, we are saying that fluorine, which is in group 17, has got the highest electronegativity, while francium, which is in group 1 and is in period 7, has got the least electronegativity compared to all other elements. Then let us look at we will look at the relationship between electronegativity and bonding very soon. But let us look at the types of covalent bonds. Covalent bonds exist in two forms. They could be nonpolar bonds. That is, electrons are shared evenly in the bond, and the resultant electronegativity difference is zero. That is, the sharing of electrons is between different atoms. It's between identical atoms. And when I say it is between identical atoms, it is as in the case of chloride. One chloride atom will share electrons with another chloride atom. One hydrogen atom will share an electron with another hydrogen atom. And in the case of methane, 4 hydrogen atoms will share electrons with one carbon atom. And we have said the total electronegativity is usually zero. Electrons in the molecule are equally shared. Like in the case of methane, as we have seen in previous slides, is that methane will result as the equal sharing of hydrogen atoms. Look at the case of methane. It is the equal sharing of hydrogen and carbon atoms that results to methane. The same case for hydrogen gas. The equal sharing of the electrons between hydrogen and oxygen is what results to their existence. Therefore, we are saying that they can be categorized as nonpolar bonds. They are between identical atoms. The other category of bonds is what we call as polar bonds. The electrons in this case are unevenly shared, and the electronegativity difference is usually greater than 0 but less than 2. If it is closer than 2, it means they are more polar. That is, they are getting to nearly being the characteristics of an ionic compound. In this case, polar covalent bonds, we are saying they have an electronegativity difference of more than 0 but less than 2. Examples include hydrogen chloride. Hydrogen is what we are calling, for it to get to a stable state, it has to form a duet. While chloride, on the other hand, it has to form what we call, it has to gain 1 electron for it to become stable. See, when you look at this, the formation of hydrogen chloride, you ask yourself, if these two are sharing 1 electron, then how is it we are saying that they could be partially ionic? The sharing of electrons and having a higher electronegativity is what makes the two elements, despite being non-metal, have partial charges. It is the same case for nitrogen oxide. And that is it for the bonding on covalent and covalent and ionic bonds. At your free time, maybe you can try to distinguish the main differences between an ionic bond and a covalent bond. But what you will realize is that a covalent bond is between nonmetals and nonmetals, while ionic bonds are between a metal and a nonmetal, and they involve the transfer of electrons, while covalent bonds involve the sharing of electrons. Thank you.